Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there. All children are welcome to tune in. This lesson is the 12th in our series. My name is Reggie Caruth, and I'm an assistant principal here in Tennessee Schools in Rutherford County. I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. So if you haven't seen any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and see previous lessons so you can, since we'll be probably talking about things previously learned today. So today we will be learning about generating equivalent ratios, again, and rates in mathematics. Before we get started, to participate fully in our lesson today, you will need paper and pencil and a surface to write on. And if you have a calculator, feel free to bring it out. Okay, y'all ready? Let's begin.
All right, y'all, let's get started with the problem that our brains engage. Problem. The given table lists the dimensions of 4 modeled rectangular bases. Look at the table of values. Describe a pattern shown in this table. What pattern do you notice? You're right, the width is multiplied by 5. So let me mark that. All of these are multiplied by 5s. Good job. What pattern do you notice about the length? Yes, correct. All of the lengths is multiples of 8. In previous lessons, we used multiplication and division to generate ratios. Today, we're going to create ratio tables to use them to compare ratios and solve problems. Y'all ready? All right, let's dive in. So here is our first problem. Our first problem says Dustin had 3 hits for every 8 at-bats. Adrian had 4 hits for every 10 at-bats. Who has the better hits of bats ratio? Do we have any baseball fans out there? Okay, good, me too. So we want to have the best at-base ratio, so let's learn how to calculate it. As we work through this problem, I want you to think about how you can compare ratios to solve a problem. The original ratios are difficult to compare because none of the terms are the same. A ratio table helps us organize the terms so that we can generate equivalent ratios. I want you to draw this table on your paper. So this table shows us Dustin's hits and at-bats from the problem, and Adrian's hits and at-bats from the problem. So now let's extend and complete the ratio tables until the number of at-bats is the same in each table. How do you generate numbers in each column to find equivalent ratios? I want you to think back to our previous lesson. Now, also, when do you think they will equal the same bats? So let's complete it and see if you're right. So from our lesson yesterday, I know to make our equivalents, I can multiply by 2 times 2. So I know that this is going to give me 6 and 16. This one will give me 8 and 20. I'm going to do the same thing. I'm going to multiply by 3, by 4, and by 5 to continue to create our equivalent ratios. So this would be 9, and 24. Now I multiply 3 times 4, 3 times 8, that's going to give me 12 and 32. And now when I do 3 times 5, 8 times 5, that's going to give me my 15 and 40. Now I'm going to do the same thing with Adrian's table. I already multiplied the first terms by 2, so now I'm going to do this one by 3, this one by 4, and this one by 5 if needed. So multiply 4 times 3, 10 times 3, that's going to give me my 12 and 30. Good job. Keep going. Now 4 times 4 and 10 times 4 is going to give me, for my equivalent term, 16. Ooh, I almost wrote 12. 16 and 40. So do I need to keep going since now I have 40 at-bats for both Dustin and Adrian? No, I don't, because that's what the problem is asking us. But if I wanted to, I can continue to create our equivalent terms if needed. So now let's interpret the chart. Dustin gets 15 hits for every 40 at-bats. And Adrian gets 16 hits for every 40 at-bats. So who has the better at-bat ratio? You're right. Adrian has more hits in 40 at-bats, and Dustin has least amount. If we had, let me ask this, if we had stopped at 12 hits, would we have come up with the same conclusion? Yes, Dustin reaches 12 hits at 32 at-bats, where Adrian reaches 12 hits at 30 at-bats. So Adrian still has a better at-bat ratio. Good job. Let's look into the next problem. All right, so this next problem I just wrote down real fast for us to try. So I'm going to read the problem aloud. It says, due to compatibility and size restrictions, only certain types of fish can live together in a tank. If there are 15 mollies in each tank with the right ratios under each of the tanks, which tank has more fish? So I'm looking at tank 1, and my ratio is 4 guppies to 5 mollies, and tank 2 is 2 angelfish to 3 mollies. So let's make a table to show the ratios of guppies to mollies in tank 1 and in tank 2. So let's start off with making a ratio table based off our problem and what we know. So I'm gonna start filling in what I know about tank 1, which was 4 guppies, 5 mollies, and I know there were 2 angelfish to 3. So just like in previous, when we created our equivalent tables, I'm gonna multiply by 2, 3, 4, and 5 until I get that there are 15 mollies. So let's work through it. So I'm going to start off with multiplying by 2. No, 4 times 2 is going to give me my 8. 5 times 2 is going to give me my 10. 2 times 2 is going to give me my 4. 3 times 2 is going to give me my 6. Now I'm going to multiply by 3. 4 times 3 is going to give me my 12. 5 times 3 is going to give me my 15. 2 times 3 is going to give me my 6. 3 times 3 is going to give me my 9. So my next, I'm going to multiply by 4. 4 times 4 is 16. 5 times 4 is 20. 2 times 4 is 8. 3 times 4 is 12. I'm not up to 15 milliliters yet, so let's keep going in both tanks. I have it in one. I need to keep going in my next one. So I'm going to multiply by 5. 4 times 5 is going to give me 20. 5 times 5 is 25. 10 and 15. So now, looking back at my tank, I see that I have 15 mollies to 12 guppies. Same thing here. I have 10 mollies to 10 angelfish. So let's look at the original question. We want to know which tank has more fish. So what do we need to do next? Correct. We need to find the total in each tank so I can know which one has more fish. So which tank has more fish? Let's try. So I know tank 1 has 12 guppies to N 15, which is going to give me a total of 27 fish in tank 1. Let's do the same thing with tank 2. I know 10 plus 15, that's going to give me a total of 25 fish. So now looking at it, I can see since 27 is greater than 25, tank 1 has more fish. We learned that we can use ratio tables to compare ratios and solve a ratio problem by finding equivalent ratios that have corresponding terms that are the same. We've done a couple of problems together and you're doing great. Let's transition to you trying some problems and then we discussing them together. Y'all got this? Are y'all ready? I think you are. Let's do some. All right, so here's one way you can write your table. So here's our table. I have a table that shows Scott snack mix in cups, and then I have one that shows Ariel snack mix in cups. Take a minute to complete the table. Then use the table to find who makes a larger batch if they each use 6 cups of almonds. So go by what we've previously done. We're filling out ratio tables, and I want you to fill in this table, and I want to know who makes a larger batch at 6 cups. All right, so if there are 6 goldfish in each tank with the ratio shown below, which tank has more fish? So I see tank 1 has 1 gouramis to 2 goldfish, and tank 2 has 2 tetras to 3 goldfish. So I want you to take a minute with this information, and I want you to make a ratio table for tank 1 to tank 2. All right, so I know with starting off my table, I know I can fill in the information that I know. So I know tank 1, 1 to 2, and tank 2, 2 to 3. All right, I'm gonna give you a second and I want you to finish filling in your table. Okay, so now I know I can multiply by 2, I'm gonna multiply by 3, by 4, and by 5. Same thing here, by 2, by 3, by 4, and by 5 to get my equivalent. So this would be 2, 4. This will be 3, 6. Good job. This will be 4, 8. And then this one will be 5, 10. Great job, y'all. This one will be 4, 6. This one, 6, 9. This term, 8, 12. And this term, 10, 15. So now, which tank has more fish when there are 6 goldfish? So which tank has more fish when there are 6 goldfish? What do you need to do to answer this question? Right, you need to find the total amount of fish in each tank. Do that now and then we'll discuss. All right, so which tank has more fish? You're right, tank 2 actually has more fish. Let's check and see what you did. So if I had from here 3 plus 6 to give me a total number of fish in this tank is 9. And then same here, 4 plus 6 to give me 10 fish. So tank 2 has more fish because it has 10 fish in its tank when there are 6 goldfish. Good job, y'all. Okay, I want you to try this next problem on your own, and I want you to create a ratio table to see what answer you get. So here's your problem. Here's your problem. To make plaster, Kevin mixes 3 cups of water with 4 pounds of platter powder. Jenny makes plaster using a ratio of 4 cups of water to 5 pounds of plaster powder. If they each use 12 cups of water to make plaster, who will make more plaster? So I'm gonna give you some time and I want you to try this. Create a ratio table and I want you to see who will make more. All right, so let's create a ratio table to see if you got what answer you got so we can compare. Here's my table. Let's start filling in what we know. I know that Kevin starts with 3 cups of water to 4 pounds of plaster. Jenny, same thing, 4 cups of water for every 5 pounds. So I can keep going until I get to 12 cups of water. So I know I can multiply by 2, by 3, and by 4 to get my 12 cups of water. So 3 times 2 is going to give me 6. 4 times 2 is going to give me 8. 3 times 3, 9. 4 times 3, 12. 3 times 4, 12. 4 times 4, 16. And I can stop here because I know I'm looking for 12 cups of water, which gives me 16 plaster. Same thing here. I can multiply times 2, times 3. 4 times 2 is 8. 5 times 2 is 10. 4 times 3 is 12. 5 times 3 is 15. So I can stop here because this gives me my 12 cups of water for Jenny for 15. So who produces more? You're right. Kevin does. Good job.
All right, great work. Today we review ways to generate equivalent ratios and use them to compare ratios. I hope you're seeing some connections to problems you can solve around the house. You sure did do a great job. After the video, you'll have some problems to practice on your own. I will show you the independent practice problems now, or you can find them on the Tennessee Department of Education's website at www.tn.gov/education. Good luck and thanks for hanging out with me. Students, I have really enjoyed comparing ratios with you. Thank you for inviting me into your home. This has been fun. I look forward to seeing you in our next lesson in Tennessee's at-home learning series. Goodbye.
We know this year didn't go according to plan. Life occasionally springs a pop quiz on you, but you passed the test. Your family is proud of you, and Tennessee is proud of you. This year may have been different, but you met the moment and graduated. And we, at the Tennessee Department of Education, want to spend the next few weeks celebrating your accomplishment. Congratulations, class of 2020.
Hello, my most amazing artist. Today, you're going to be creating with me. My name is Cassie Stevens, and I love creating. If you love making things as much as I do, you can find more videos just like this one on my YouTube channel. You can find me at Cassie Stevens. Today, we're going to be making something called origami. Origami is the Japanese art form of folding paper. Did you know that you can take a flat piece of paper and transform it just by folding it? Today, we're going to be transforming a piece of paper and creating a home. You could create your home, maybe a fantasy home, a beautiful home that one day you hope to live in. Speaking of home, when you're finished decorating it, you can share who is inside of your home. Maybe drawing your family, your pets, and more. All right, guys, let's get started. To create your origami house, begin with a vertical piece of paper. Take the top of the paper and bring it down to the bottom. Hold it in place and then fold in half. Now take the left side of your paper and bring it over to the right. Sometimes that can be tricky. Paper isn't always easy to fold. Be patient with it. Once you've got it folded in half, unfold. Bring that left side to the center fold. There you go. This will be one side of our house. To create the roof Open that opening right there. Bring it down and squish the triangle down. Same thing on the other side. Bring it over to the center fold. Flatten it, open it, and bring down the roof. There you go. Can be a little tricky. A little practice can help you out. House is finished. Now let's decorate the outside of the house. It could look like your house. It could look like a friend's house or a family member's house. It could be a house of your dreams. The choice is yours. This is your masterpiece. So decorate it with a windows, some doors, flowers, plants, add a texture to the roof. You get to decide. Once the outside of your house is complete, what's waiting on the inside? Could you draw your family? Could you draw your house pets? Could you draw the furniture within your house? That's up to you. I'm going to focus on the people that I love that live in my house. I'll start with me. I'm just using some simple shapes and maybe even some other family members and my pets. Once you're all finished, then you can start to add color. You could use crayons, markers, and colored pencils. The choice is yours. Have fun creating.